Let us move on to the next presentation, technical paper number 2, monitoring of remote substation through robotics, augmented reality and artificial intelligence by Tata Power Company, Carnac receiving station. Please.
Good afternoon all. Myself Ravi Sahu, we are representing Tata Power Carnac receiving station transmission. Our paper is monitoring of remote substation through robotics, augmented reality and artificial intelligence. Our team members were Mr. Kumar, Mr. Ashish Matre and Mr. Manish Gu. So just a brief what is remote monitoring and why it is needed. So remote monitoring of industrial assets, complex physical equipments has proven its value across a range of verticals. As company seeks to drive through value more reliable and digital laden products, implementing remote monitoring will become increasingly mandatory to compete. Early adopters have already established the early advantage of position themselves with best class in services. So what is remote monitoring? Remote monitoring is ability to view machine status, performance and behavior from a distance. This is mainly accomplished through a combination of Internet of Things, that is IoT, and cloud computing to track machines' performance. This allows an asset that is on-site in a factory, hospital, on the road to be visible to the parties responsible for preventing breakdown or in the event of an unplanned shutdowns or outages. So we have a remote substation, that is Grand Road Receiving Station, that is under our consumer premises PST. So this Grand Road Receiving Station is situated in premises of PST Ketwadi Receiving Station. In that substation, Tata Power assets includes 110 kV GIS, consists of two lines, Carnac Grand Road and Parel Grand Road line, and there is one bus coupler. There are three floors: relay room having control panels, RDO metering panels, UPS. There is one charger room where 110 and 48 volt battery chargers are there, and there is one ACDV and DCDV auxiliary supplies. So the trigger for improvement is that the operation engineer, that is SMC engineer, in every evening shift has to take daily rounds and travel to the remote substation. The SMC engineer average traveling time is around 45 minutes from Carnac receiving station to Grand Road receiving station. It may further increase to subject to the traffic situations or in the rainy seasons. When the SMC engineer goes there, he has to fill the checklist of condition monitoring, that is in the GEAPM platform using tab. There are around 61 points including the condition monitoring checklist. This whole process will take around 2 to 3 hours for completion, and time cycle for daily rounds needed to be reduced by eliminating personal visits of the operation engineer to the remote substation. Hence, one augmented mechanism was required for condition monitoring from remote location, that is situated at Carnac. So by brainstorming and discussion, we further drill down to the solutions, that is whether we can do the live video streaming, automated station rounds, first-hand information to the operation engineer about the conditions, notifying the abnormal conditions, and whether we can implement the augmented reality and artificial intelligence features. Next. So by discussing, we have developed whether we can implement a robotic prototype with the AR and AI application, and how we can get the real-time data with the help of the communication link. So this will be combine a real-time condition monitoring. So we have developed an in-house robot, this robotic prototype. This robot is a line follower having a line sensor for detection of path. It is having a proximity sensor for detection of obstruction. Equipped with camera mounted on the slider for vertical movement. Camera resolution is 12 megapixel with 5x optical zoom. We have installed a track with the RFID sensors for detection of RFID tags. In front of each panels, we have programmed and installed an RFID tags. It works on the electromagnetic principle. On robot, there is a RFID sensor is installed, which detects this RFID tags and stops there. Remote command web server development replying camera footage is done through ARM processor. Motor controlling is done through 80 mega microcontroller. It is mounted on the robot. It is powered with 12 volt 7 ampere hour battery, enough for taking 3 and 4 rounds with one full charge. Next. So this idea development was with the incorporation of RFID sensors, proximity sensors. There is one Mega 6 microcontroller which controls the movement of the camera. This robot is mounted with the wheels, motor, driver unit, sliding motor unit, and the robot movement is controlled through the ARM processor. Camera visuals for live video streaming and condition monitoring, and one workstation for recording of the data and report generation. So these are the list of the panels installed at our remote substation. Next. So this idea development is this is a pictorial view. There are a number of panels. There are two rows in between the panels. So we have laid one track with the installation of RFID tags. This robot moves particularly on these tracks, and it detects the RFID tags and stops there. For 20, we have programmed that it will take rounds for automatic as well as manual mode also. In automatic mode, robot started itself, takes it detects the RFID tags, stops at particular in front of panels, waits for 20 seconds, and then move to the next panel. This is just a brief how at Carnac receiving station we have established a communication link through OT platform. This is 10 MB PS we can for live video streaming. Next. This is a pictorial view of how we have achieved this live video streaming and storage of data. So how AI and AR play a vital role for this condition monitoring? Advanced augmented reality features were developed to superimpose real-time data and virtual objects onto the real system environment. So AR application puts real-time information and relevant information at your fingertips whenever and whatever is needed. Digital application developed to guide real-time operation and monitor the parameters of all station equipments. So as you can see, previous slide, we have installed particular barcodes in front of particular LEDs. With the help of the camera and image analytics, we have captured the normal and abnormal conditions. By AR and AI application, we are continuously monitoring and comparing the images, and if there is a difference, it can pop up an alarm. So we have installed particular barcodes for every LEDs. So QR code need to be scanned at the start of predefined route. In case of some reason the round is suspended, can be resumed from the last equipment. Default data and limits are set to alert for any abnormality. With the help of robotic prototype, human intervention is eliminated and time set for traveling to the remote station. So QR code implementation include every point is mapped with one QR code for detection. In database information of that point, its normal and abnormal state image is stored. Real-time artificial intelligence analysis is done with the respect of images stored in the database. So as you can see in the picture, for every LED there is a barcode installed, and with the help of AI and AR, we have and through image analytics, we are comparing the images and generating the alarms. As you can see in this image, we have developed HTML and JavaScript. We have developed a manual web page. We have given the number of panels in the manual web page, and as you can see, there is one automatic and there is one manual round also. So by pressing this automatic, the robot starts itself, take the round. Take the round and generate the report itself. It will be in Excel format. And in case there is any tripping in the remote station and we have to take the manual rounds, so you can give command from the particular panel, robot goes to the particular panel, and the live streaming of the particular abnormal conditions you can see sitting at the Carnac station. In case you can found battery is draining or there is any obstacle, the robot stops itself. You can stop the robot from here, and again you can start from here. If the image is not clear, you can zoom in, zoom out from the camera from here. Next slide. As you can see, this particular panel, this breaker is closed. So with the on indication lamp is glowing. With the help of this artificial intelligence, this pop-up generates 52 CB close. And this all pop-ups we have mapped to the report also. So it will generate an Excel format and the report gets stored. You can analyze the reports whenever, or you can submit the report to your HOD. Next. This circuit breaker, trip circuit relay healthy, lockout relay. Next. So implementation modalities, all observation of O&M rounds are by using remote robot program to work automatically to take station observation rounds using a AI platform on the workstation at Carnac station. The customized GUI display is designed to feed video feed from the robot. Real-time artificial intelligence based alarm display in a systematic way and without any manual intervention. The AR features will provide device selection, default status, data sheets, QR access, etc. All AR features will be available on the Carnac workstation for the O&M engineer, and the information of the assets can be observed and syncs with the central server. What are the benefits? The condition monitoring by O&M personnel will have significant time saving, and hence more stations can be added to the daily maintenance rounds. Ease of recording data and abnormalities on the go. Step-by-step procedures can be programmed to restore the system faster while troubleshooting the devices systems. Complete station system equipment details will be available on the AR view, and hence carrying a physical or manuals, logs, logics, data sheets will not be required. This will have significant time and maintenance operation. Can serve as an effective tool for training new engineers on all different OEM makes and types of system equipments. As the pop-up appears, we can attach the manuals, standard SOP also. So by scanning the particular barcode, you can click the station particular SOP also. You can go through the control drawings also can be attached to the particular barcodes. Key benefits of the projects: reduction in total cycle time of condition monitoring rounds, eliminates human intervention and reduces traveling time taken for remote station, user-friendly interface for ease of operation, improvement in equipment availability in case of shutdowns and troubleshootings, auto time stamping for each station round, real-time data monitoring, default value reduces number of clicks, reduction in paperwork, remote assistance during emergencies. The preparatory work for this idea development was making smooth and level surface for proper movement of robot, laying tracks on the floor, additional lighting arrangement. As initially we have installed the barcodes, but due to reflection and something, the barcodes were not scanned properly. QR code printing and putting on the panels for every point that needed to be captured in the condition monitoring. Building database for advanced AR and AI applications. Simulation of the fault protection panels of 110 kV lines and bus coupler, bus bar panels, UPS panels, etc. As I earlier said, you have to capture both normal and abnormal images so that it will compare and then it will generate a pop-up. So for simulating them, we have to take the outages of the particular lines. We have to inject the current in the secondary circuit. We have to generate LEDs and capture each LEDs along with the barcodes. Capturing photos of status LEDs of relay denoting abnormal as well as healthy conditions. Next. What are the challenges faced? The space constraint in relay room at Grand Road between two panels was very less. So for turning off robots and laying tracks, it was very difficult. Camera movement is only in vertical dimension. RFID detection on uneven surface was difficult, so we have to lay a smooth surface. With the zero level, we have checked the surface, because if it is uneven, the RFID it will skip the panels. Robo will skip the panels. Camera with limited zooming facility capability, detection of QR code, which was smaller in size, was very difficult. Glazing and reflection on panels door causing issues with the detection of panels. And as I earlier said, outages taken for fault simulation and cleared in minimum possible time. Next. The future prospects of this project is wireless charging of robot battery, because in initial times we have to go there, remote substation, charge the robot so that it will take the rounds. So now we have developed a wireless charger, and we have given one command prompt in the web page also. From there you can monitor the battery voltage with wireless facility, and we have designed a parking area where the charger is installed. Robot itself goes to the parking area and it will charge automatically, and you can monitor the battery voltage from Carnac station. Historical server can be maintained for keeping records of the round data. Automated robotic rounds can be scheduled for particular intervals, so you can program at what time you have to take the automatic round. You can schedule the interval and the robot start itself for taking rounds at a particular interval. Smoke detection and fire hazards can be incorporated, and firefighting capability can be developed in the robot also. That are the future aspects. Thank you.
Thank you. No clap? I have one particular question,
Yes.
not to challenge you, but to give you a little extra thought. This particular system, what you have installed, why you have thought of installing on the way? It could have been hung from the top through a monorail.
Sir, we have tried.
Let me finish. I have not finished my question. Because I did not see any marking of arc flash zone and clear green zone when you are talking of a regular equipment going every off and on and trying to take the regular monitoring of the data. It should be in a green zone, but it is not seems to be in a green zone. Maybe your substation is very old and that much space is not there. So I strongly feel you should hang it from the top through a monorail, so that problem is also sorted out, and wherever it has to come, it drops down. Again, after taking reading, it goes up and it gets locked at the end. Think over it.
Sir, initially we thought of a horizontal slider with the help of fabrication work. But what the challenges we have faced with the limited zooming capability of this camera, from a distance it is very difficult to scan the barcode. The camera needs to be particularly focused on the particular LEDs, and in one frame, one LED should come. If there are 2 or 3 LEDs come, there is a confusion. So what barcode the camera has to scan. So initially we thought of with the horizontal slider with the camera mounted in it, and it will particularly zoom to the particular panel. But from the initial phase, we have faced this problem, and there are a lot of reflection as the lights are mounted on the top of the floor. So when the camera moves, it will block the lighting also, and there are few reflections which will block the scanning of the barcode. So initially we thought of,
Then provide a arc flash suit to the system.
and this is a low voltage panel, sir. There is no harm, but in case there are high voltage systems like breakers and some condition monitoring is there, we can thought of.
Think of.
Yeah.
Good.
Thank you, sir.
Thank you.
Thank you very much. This is the end of our second technical paper.